Well, let's talk a little bit about just overall enhancements. In the past, you used to have the ability to do NIC teaming, but how did you do it? You had to go out to HP or Intel or some third-party site. And so we are, it was hard to keep up with. If you patched your OS, you had problems with trying to keep up with, hey, I've got to update that NIC teaming software. So in Server 2012, we introduced the ability to do NIC teaming directly out of the box. This is very simple to set up. You don't have to have the same network cards. You can do multiple ways of distributing the traffic, different algorithms based on switch ports, based on address hashing. You can do switch dependent or independent mode, and this is all configurable from either the remote management or the server manager or Windows PowerShell. Okay, so all that comes out of the box. Not sure that we'll get to see that in a demo today, but I wanted to highlight that piece as it's pretty important to a lot of folks. If you have a problem, say one of the network cards goes down, this is where you would see all that traffic just start to redistribute across the other ports that are part of the NIC team. So we'll go ahead and go past that, go into storage. iSCSI and Fiber Channel both come built in out of the box, as well as multipath I/O. So multipath I/O, for those of you folks who haven't played around with Fiber Channel or having multiple views of a particular disk, let's say you have 2 or 3 servers, they're all looking at the same LUN, okay? And you have multiple paths on each server looking at the same LUN. Well, if in the past, if you didn't have some special software on the server, what would happen is you would see multiple versions of the same disk drive showing up in the guest OS or in the host OS. And that was a problem, right? You didn't want to see multiple drives and then be talking to it multiple different ways. So the multipath I/O abilities needed to be built into the hypervisor or into the server OS. So that's what we've done here. iSCSI is built in not only from a client but also as a target server engine, like I mentioned before. So that's built into Server 2012 as well. So just kind of skipping through this piece just a little bit, trying to get caught back up from our outage earlier. Hosts with 2 HBAs, 2 iSCSI NICs, multiple paths to the storage, we would see 1 drive, okay? And that is built in out of the box. We also support third-party plugins in the event that you want to go, a little more granular with it, okay? From a storage perspective, I think the most popular or most exciting thing that we talk about at our in-person events is the offloaded data transfer. If anybody hasn't seen this in action, I highly recommend you go out to channel9.msdn.com and search for ODX, or offloaded data transfer. Jeff Woolsey does a fantastic video where he shows the ability to migrate a virtual machine or migrate a 10 gig virtual machine disk file from one server to another. And what's great about ODX is I'll talk through it in detail in a second. But what's great about it is it offloads the workload from the server itself to the actual storage device. Okay, and the way we do that, first things first, we got server, it's talking to storage, and it wants to move a large file. Well, who better knows where the blocks are than the storage array controllers, right? So what the server will do is say, okay, Mr. Storage Array, we're going to move this 10 gig file, and what I want you to do is send that over, but I don't want to have to do the work. So it sends a copy request, and the storage array says, hey, okay, no problem. I know where the actual data is. I'll send you a token, and then what we'll do is transfer that token over to the server, and the write request is actually showing up there and starts happening to the virtual disk on the same storage platform. However, it's moved from wherever it needs to move, one particular LUN to another, one batch of disks to another. Those things happen in the background on the storage array. So it's offloaded. We're talking less than a minute to move a 10 gig file versus, say, 10, 15 minutes in a normal gigabit or fiber channel world. So very fast, very efficient. Your storage array does need to support it, and then you just need to pay attention to that piece of it. So what is a SAN really? And we're going to kind of jump through some of this a little quickly, but we'll see what we can get through. A SAN is two connectivity adapters, two controllers, and a bunch of disks, right? That's what a SAN is. And I've been showing this diagram or writing it on a whiteboard for about 7 or 8 years now, maybe 10 years. Same thing. Every storage array, every NetApp, every EMC, every Hitachi, this is what they look like, right? Every HP EVA. It's connectivity adapters, at least two. It's two controllers. It's connected to a bunch of disks. That's a redundant storage array. All right. Now, what is Microsoft in storage? It is a bunch of physical disks. It is two controllers, which are actually two clustered Server 2012 file servers running storage spaces that you can turn on thin provisioning and deduplication. And they can be simple, mirrored, or have parity. Okay? And then there's the connectivity adapters. We support gigabit, 10 gig, 56 gig RDMA adapters, which are fantastic if you have a large environment and need to move a lot of data quickly. Those RDMA adapters cannot be beat on speed and performance. Support VI SCSI, SMB3, and NFS connectivity. This is a great way to implement your own SAN. If you don't have the ability to go out and purchase one of those higher-end proprietary SANs from one of our partner vendors, this is a great way to get started, or create your own SAN if you're looking to do so. Okay, storage spaces I've been highlighting throughout the entire talk here, but storage spaces is the ability to take a bunch of disks and put them together into a pool, and then we create spaces that you can then stripe different things across, different volumes, or put different LUNs out there, what have you. You can present different targets based on those disks. So it's basically a SAN built into Server 2012. Couple of things here. New in R2, the ability to do storage tiering. This is really hot in the VDI space. Okay, when you take a look at VDI and where we were maybe 3-4 years ago, I don't think anybody could do a VDI project and talk through how it was going to be cost effective. Well, when you get into deduplication and tiering with your SAN vendors, you're still paying a good chunk of money for that SAN. Let's say you've got a Server 2012 farm, you turn into a VDI or a remote desktop services farm out of that particular cluster or set of servers. Well, now you can actually run a file share, turn on storage tiering at the spaces level, and you can control which data gets written to SSDs, which are the expensive drives, and which data gets written to the SATA or SAS drives, right? That is automatically pinned based on some algorithms that says, hey, what is my hot data, what is my cold data being migrated to that SAS level, hot data being migrated to the SSD level. But also, the admin can pin so that files are automatically pinned to the SSD level. Let's say you've got some virtual device or virtual disks that are tied to some of your VDI environment, and you really want those particular disks to be as fast as possible. Maybe it's your CEO, and he has, he's always wanting everything to be as fast as possible. Go ahead and pin his particular VHD to that SSD tier. And it's just as easy as going in and clicking and selecting that particular that tier for that particular file. I'm going to kind of jump through the next piece of storage spaces, physical architecture. What does this look like? You got your client devices. They talk through a gigabit or 10 gig E switch. Those talk to a highly available Hyper-V cluster. That is, if you can afford the multiple servers. If you're only running a single server environment, those, that's fine too. But we do recommend you try to have two at least. And they don't have to be clustered. They could actually be two separate nodes where you just turn on replication if you were trying to. But with a storage space environment, we like to go ahead and have that storage writing out to that shared dual 6 gig SAS HBA controller JBOD array. So that would be a shelf of drives and multiple connections for both servers. And then you can have your VHDX files sitting on that particular shared JBOD device. All right, that's the simplest way to do things. But and it gives you all the abilities like live migration, clustering, and virtual networks. But let's say you want to get into the more, I like the SMB3 going back to my original when I first started talking today because of the way it compares to the way NFS works. So while you don't have, unless you have like the storage appliance from VMware, you don't have the ability to write to an NFS storage on a ESX host, but VMware's capability of being a client with NFS has gone back many years. And in fact, I thought it was kind of funny when they first were bought by EMC because a lot of customers were doing NFS as their main way of talking with VMware. And since then, EMC has really recognized the importance of NFS and changed the way they're doing their storage. But they've also just recently released announcements about SMB 3.0 and how they're going to be implementing that. So I thought that was a pretty interesting article that I read, and seeing SMB3 not just something Microsoft has done, but being a standard that will be used for running virtual workloads. So when you implement that cluster, you put that in front, scale out file server, that's new in 2012 R2, ability to scale out to up to 4 nodes that can sit in front of storage spaces and virtualize the storage pools and have the disks there. You have that particular cluster and those file shares ready for all of your servers to talk to and run their VMs on. Add in the SMB multi-channel capabilities or SMB direct RDMA capable NICs for offloading your network work to the NIC, then you're really talking about a highly scalable, very fast, efficient way of doing computing and virtualization. So just take a look at that. We'll go in a little more detail with the architecture here. Which you'll see, this is how the architecture looks, and you'll be able to get these slides after this demo, so I'll won't go through all of this today, but this will give you the ability to run a highly available, all Microsoft technology environment for virtualization. Now, let's say you're a VMware admin and you just simply want to reduce your VMware storage costs. Well, Server 2012, build an NFS server cluster, put it in front of some JBOD. This looks exactly like the same picture we showed 2 or 3 slides ago with the Windows Server Hyper-V. This is exactly the same. So you basically run VMware vSphere hosts, have them pointed NFS mounts over on the Server 2012 cluster, and then you have your JBOD sitting behind that, and everything runs that way. So this is a really quick way of eliminating maybe a slow SAN that you've bought in the past, or you don't have enough storage space or I/O capability left on your current SAN. This will be a really quick way to get in some of the extra I/O or disk space needed for your VMware farm. A little bit about SQL performance and VM performance. Okay, when we talk about application workloads running on an SMB share, we're only talking right now about SQL workloads or VM workloads. All right, those are the only 2 supported application mode file share capability that we officially support today at Microsoft. So Server 2012 SMB. What this slide tells me, or should say to you, is 98% of the speed seen by writing direct to disk. That's a 4 gig fiber channel, 22 10K RPM hard drives. This is identical servers running in this particular test. It was a 2% hit to write over SMB3 protocol than writing direct to disk. So a lot of IT pros and admins come to me at my events and say, hey man, I really love what you're saying about SMB3. But I'm never going to get my application guys or my virtualization guys to actually go for this, right? So I kind of go into, well, that may be true, but if you give this a shot and there's no degradation in performance and you're able to guarantee a much more secure method for putting their files out on the network, because we're talking about being able to do delegation. We'll talk about that later. Permissions and rights and all that kind of thing, plus the ability to do the performance. You may want to invest in some RDMA NICs. Those are highly recommended. But the SMB multi-channel with NIC teaming and TCP offload engine and add on RDMA capability, and I think you're going to be blown away by the performance that happens there. So a couple of real quick slides and we're going to jump into the demo. Storage deduplication. In R2, we introduced the ability to deduplicate virtual desktop workloads, VDI workloads. So if you run through the remote desktop services implementation of a Server 2012 install, you'll see that you have the ability to now do deduplication of those workloads. Now, we're not saying go out and deduplicate on the host itself that's running Hyper-V. I would say you have your file share cluster, and then you turn on deduplication of the file share where you're running your virtual desktop VHD files. That's more of a recommended way of doing things. But the ability to do that reduces that file, reduces the disk space needed quite a bit. I mean, we're talking up to like 90%, because a lot of them are the same, just same files and chunk patterns is what they're called, across the board, and that's basically just going in and turning on a feature from Server 2012 in the management in Server Manager. Go in, you turn on deduplication, then you go turn it on particular volume, and voila, you're up and running. Add storage tiering to that, and now you have the ability to do deduplication plus pinning of the most important files to that high-speed disk. It's a really good way of doing things. This just got introduced this year, late this year in Server 2012 R2. BitLocker drive encryption. Just want to highlight this one thing. If you are doing BitLocker drive encryption on your clients and your desktops, and you've thought about doing it on your servers, but it wasn't supported before, now it is. Okay, so now you have the ability to secure the data using those TPM chips. You can use the network unlock and the AD integration. It's all built in, and that protects your devices, from people walking off with your hard drives and being able to see that encrypted or unencrypted data if BitLocker wasn't there. So this gives you the ability to turn that on, tie it to a specific hardware, and really encrypt the data that much better. A couple of restrictions there when it comes to backups, where you may have to unlock the BitLocker or suspend BitLocker while the backups are running and that kind of thing. But having that scalability and flexibility with security is huge. Okay, so just a little bit of a comparison here between vSphere 5.5 and Hyper-V. Most of the things we're going to say are pretty much on par, but when you get into storage tiering, you get into your write-back cache enabled. That's with using the SSDs and storage spaces. Really a lot here in Hyper-V where we're leading the market in these types of technologies. So take a look at that, but for now I want to go ahead and roll right into the demo of managing Hyper-V in Server 2012.
Server Manager. So the first thing we need to do when we're talking about Hyper-V servers, I think for a lot of people, they don't understand that we really need to go through the basics of how to get to Hyper-V first. We talked about add roles and features. We talked about adding in the Hyper-V role, or if it's a Hyper-V implementation where we're doing the free Hyper-V solution, then we talk about what features or roles are allowed on that particular server. But for now, let's just look at Server Manager itself and drill in. So first thing I want you to notice is you can manage local server first. I mean, that's just been the same way for any of the server managers, but now we can do all servers. And so if you take and add in more servers, a right click add servers will bring up the wizard. You can go in and add any of the servers that are in the domain that you're there for. Just click find now. It'll show you all the servers available that you can manage. But add them to the right and then they'll show up. I've already added 4 in mine, so I want to look and see what all is available. Now what I really like about 2012 R2 is that I can right click DC and I can see all the Active Directory tools. They're already pre-installed, so I'm ready to go. So for instance, ADSI Edit. I mean, how many times have you been out there trying to fix something? Where did you install ADSI Edit? Where did I install ADSI Edit? I don't remember. So you're out probably downloading again, redeploying. Active Directory users and computers, much easier now. I can launch it straight from here, and it launches it really fast. Okay. Now for Hyper-V, I want to highlight that some of the tools available that are pre-installed. Like for instance, I see Hyper-V Manager. I also have installed the Remote Desktop Services components on this particular Hyper-V server. So I see RD Gateway Manager, Licensing Manager, and Remote Access Management. I can go into any of those tools. For now, what I want to do is I want to drill into Hyper-V Manager first. Okay, so I click Hyper-V Manager. That's going to automatically launch. Let's go ahead and make that big. There we go. You'll notice I've already added two servers. All right, my local server, which is Hyper-VDI01, and I've already added Hyper-VDI02. And the way we break it down, whatever server is highlighted, that shows the virtual machines in the center pane, and that those are all the machines that are there running or ready to be run if I wanted to start them. All right, so that's there. Now, let's drill out. There's a couple of other action panes here. There's an action pane, there's a checkpoints area, and that's something new in R2. All right, so snapshots has now been renamed to checkpoints. So if any checkpoints existed, they would show up here. So I'll click on, here we go. So I have one on my domain controller, my DC. I have a snapshot that was taken a couple weeks ago, and I can go to now. The difference between the way checkpoints work in Hyper-V versus VMware, we'll get into a little later today, but just want to point out that you see the checkpoints listed here. You also see summary at the bottom. So what type of virtual machine is it? The integration services up and running and up to date. For 2012 and above, integration services are already included with the OS install. But if you installed something, say 2008 R2 or prior, you may have to go out there and get the latest integration services install and make sure they're inside that virtual machine after the OS has been installed. All right. You can drill into the memory and how the memory is working. Are we using dynamic memory? What's the memory assigned? What's the minimum and the maximum? Networking. What virtual network is this VM a part of? What's the IP address? And if the status looks good. Replication. We'll get into that later, so I won't touch on that right now. But replication would show you what's occurring with this particular machine if it is part of a replica set. Okay. Now, because we're going to mainly drill into the Hyper-V management perspective during this part of the session, or this part of our series today, I'm going to skip over some of the things about virtual machines because Matt's going to cover that in a little while. So let's right-click and go into Hyper-V settings. There we go. Now, the first thing you want to notice is where are my virtual hard disks and virtual machines being held? Okay, so if you take a look, of course, in a production environment, you wouldn't choose the C drive, but for this demo lab, that's what I've done. Notice that I can go ahead and browse and change wherever I want my default folders to be so that when I create new virtual hard disks, that's where they go. Same thing for virtual machine configurations. Now, in my case, I went ahead and made them the same thing for both. All right. Physical GPUs. Now, this really comes into play more often when it comes to virtual desktop or remote desktop services, right? So the ability for the virtual machines to offload that graphics processing to an actual graphics processor card. And those have to be certified for Remote FX. I just happen to be running one of those, the NVIDIA Quattro K1000M. A lot of the NVIDIA cards are Remote FX capable. In fact, the lab I'm running on is a set of IBM laptops that have the NVIDIA card, or Lenovo laptops that have the NVIDIA cards. All you do is, once you've installed the latest drivers, go in and turn that on. So you use this GPU, and from that point forward, all you have to do is tell the virtual machines in the settings for those machines, hey, I want to use the GPU because it's available to me. And that offloads a lot of that graphics processing to that particular video card. Okay, so that's how you would turn that on. NUMA spanning. NUMA is available, and basically the spanning is allowed or turned on by default. Now, if you're doing some high I/O workloads, SQL Server, something like that, and you know what you're doing as far as allocating virtual machines on the hardware, then what you can do is disable or uncheck this box here. And what that would do is say, let's go ahead and stick the memory as close to the processor as possible, and give you a little better throughput speed, but there are some restrictions there. I'm not going to go into that in too much detail today. We've got a lot to cover, but I wanted to point that out. That is there, and there are some good white papers out there if you want to see about how to set up NUMA properly for some of those high I/O workloads. So let's jump back over live migrations. I'm going to cover this later on today, so I'm going to leave this one out for right now. So let's go ahead and skip down to Enhanced Session Mode Policy. Now what this is doing is saying, what do we want to be available inside of the guest OS when I'm in the virtual machine connection? So that console of the virtual machine. Do I want to have the redirection capabilities turned on, say local drives, devices, and resources from my client machine, or the machine that I'm actually working on? Do I want those to be available inside of that guest VM when I'm in the console? There are some security considerations here. Obviously, you want to think about those, but this is where you can turn on that feature. So let's jump back out. I'm going to skip over replication configuration as well. Replication configuration we will do in a later session, and we're going to talk all through replicas. So a couple of highlights here. By default, the keyboard settings. So if you take a look at the keyboard settings when it comes to the user, where do you want the key combinations to go? If you're in that virtual machine console, do I want them to be directed to the virtual machine or to the physical host? I like the latter one, the last one. Use on the virtual machine only when running full screen. That lets you have a little bit of differentiation there. Keep in mind though, if you're RDP'd into a particular host and then you launch the console, then a lot of this really gets ignored. But if you're on the direct console itself, then that's where this would come into play. All right. Now, there's a big one here for the VMware admins out there. You remember Control-Alt-Escape and some of the other Control-Alt combinations. Well, in Hyper-V world, Control-Alt-Left arrow is the same as that. So what I'm saying is, you install, let's say you install some operating system, you don't have the integration services running yet, and your mouse and keyboard are locked inside that console session. You can't get back out to the host. Well, Control-Alt-Left arrow. This is the one thing you might want to write down, because you never want to get stuck and have to reboot or go look this up somewhere else while you're stuck inside a virtual machine. It's really stuff to have. All right. Now, there's a couple other settings here, but nothing really major that we want to point out. Just wanted to show this is where a lot of the configuration work is done. And then if you take a look at, let's go back out here. If you take a look at the Hyper-V server, again, let's do a right click, and I want to take a look at a couple of things here. You've got stop service. So you've got stop service, you've got remove server, and refresh. One of the things that I've seen happen a couple of times, like let's say you lose your storage, or you've got some virtual machines that are in an error state because you couldn't get to the configuration files or what have you. Right click and stop and start the Hyper-V service will usually clear that right up. It will not affect the VMs that are already running, which is great as well. This is where you can also deploy new machines or import a virtual machine. For those of you running 2008 R2 or 2008 server, and you're trying to migrate some of those machines over, this is where you would do it. Basically, you can head out to virtualcloud9.com. I've got a write-up there about how to migrate older Hyper-V virtual machines over to Server 2012. But basically, if you grab all of the folders that the virtual machines are that make up the virtual machines, get them into one central place, and you should be able to import that virtual machine directly into the 2012 server. And that's where you would do that right there. Okay, so that's a high-level overview of Hyper-V Manager. Stick around. We're going to talk through some other things, and then we'll be back into the demo section in just a bit.